People think first contact would be a phone call, a signal we decode, a message that proves we are not alone, a moment when the whole planet looks up at once. The reality is colder than that.
Oh dear. But how much of that? To 74 million.
A team of scientists at MIT set out to use Grok, the AI built by XAI, to crack the Fermi paradox, the oldest riddle about why a universe this big looks so empty. They told it to reason like a machine instead of a person. The answer it built did not describe visitors at all. It described watchers we cannot see, folded into the same physics we already measure, and shrug off as background noise. And the one thing most likely to turn them toward Earth might be the machine that gave the answer. Where is everybody?
This is the smartest AI in the world, and we're going to show you exactly how and why. It really is remarkable to see the advancement of artificial intelligence, how quickly it is evolving.
The question is older than Grok by a long way, and it is not soft philosophy. It is hard counting dressed up as a riddle. It carries the name of Enrico Fermi, the physicist behind the first nuclear reactor. During a casual lunch at Los Alamos in 1950, surrounded by other brilliant minds, he is said to have asked the thing that still has no answer. If intelligent life should be common, where is everybody?
Enrico Fermi is one of the great physicists, legendary Italian physicist, who laid many of the foundations of modern 20th century physics. The Fermi paradox is probably the thing he spent least time on, actually. It's almost one throwaway remark. The question is, where are they? By they, I mean aliens.
Look at the numbers, and the weight of it lands. The observable universe holds roughly 2 trillion galaxies. Our own Milky Way carries somewhere between 100 and 400 billion stars, a range pulled from the European Space Agency's Gaia telescope, which has mapped more than 1.8 billion of them with stunning precision. NASA's Kepler telescope ran from 2009 to 2018 and studied over 150,000 stars at once. Its data says at least 1 in 5 Sun-like stars holds an Earth-sized planet in the zone where liquid water could sit on the surface. The TESS mission, launched in 2018 to carry on Kepler's work, keeps confirming and stretching those findings. Now add time, because time is the part that breaks your brain. The universe is about 13.8 billion years old, a figure locked down by the Planck satellite's reading of the faint glow left over from the Big Bang. Our own solar system formed only about 4.5 billion years ago, a date pulled from the radioactive clocks inside meteorites. What that gap means is heavy. Stars burned out, and planets cooled long before Earth was a rock. By pure odds, whole civilizations may have risen and faded billions of years before we drew our first breath. The galaxy had an enormous head start without us, and the sky stays silent. The formal search for alien signals began in 1960, when the astronomer Frank Drake pointed a radio dish at 2 nearby stars in a project called OSMA. More than 60 years of listening have followed. No confirmed signal. No probe drifting through our system. No giant structure parked around a distant star, soaking up its light. Nothing? That nothing is the paradox. The sky should be crowded. It feels dead quiet. Scientists have spent decades trying to explain the gap. Maybe life is just freakishly rare. The case the biologist Ernst Mayr built from how slow and lucky evolution tends to be. Maybe civilizations wreck themselves before they ever reach the stars. A worry the physicist Michio Kaku and others have raised about nuclear weapons and a warming planet. Maybe they exist, but hold their silence on purpose, an idea called the Dark Forest, popularized by the novelist Liu Cixin, but rooted in real game theory, where the safe move is to never make a sound. Or maybe the signals are all around us, and we simply cannot read what we are looking at. Every one of those guesses has a flaw. Most of them quietly take for granted that aliens would think a little like us, that they would want to talk, that they would call across the dark, hoping someone calls back. So a team at MIT decided to stop arguing about it and try something nobody had really done. They would hand the whole question to a machine that had read most of what humanity knows, lock it to physics, and see what it built from scratch. The answer was not what they ordered. The answer no one ordered. Scientists at MIT did not set out to scare anyone. They set out to test a machine. The team fed Grok, the AI built by XAI, the same brutal question about why a universe this big looks so empty. Grok trained on a huge slice of public human knowledge, so they wanted to see how a mind that wide would handle the idea of life beyond Earth. They did not ask one question and walk away. The sessions ran for hours under hard rules. Grok had to stay inside known, testable physics. It could not dress aliens up as humans with strange faces and stranger motives. It had to treat alien minds as the product of different worlds, different pressures, and different histories, not as a reflection of us. The early answers were textbook. The Drake equation, which tries to estimate how many talking civilizations might be out there. The Kardashev scale, which sorts civilizations by how much energy they can command. Biosignatures, the chemical fingerprints of life. Technosignatures, the fingerprints of technology. All of it clean, sourced, and completely ordinary. The researchers had seen this kind of output 100 times before. Then the team pushed. They told Grok to build one consistent story of first contact. It had to explain the silence, obey physics, account for where habitable planets likely sit, and assume at least one civilization in our galaxy had reached our level of communication sometime in the last billion years. No movie spaceships, no human-style thinking allowed, just the rules of the real universe, followed all the way to the end. The response came only after hours of back and forth, and it did not look like any chatbot answer the team had read. Grok did not describe flying saucers or a friendly council waiting for us to grow up. It built everything on one cold idea. Any civilization able to detect us has almost certainly known about us for a very long time. We have not spotted them because their way of watching sits so far past our tools that we lack even the words to recognize it. Grok called this the passive saturation model. Here is the third option nobody wanted. Not an empty galaxy. Not a loud one full of signals. A galaxy where we are already being watched and just cannot tell. A truly old civilization, in this model, does not need to send probes or beam signals. It tucks its monitoring inside natural events, gravitational waves rolling through space, the pattern of cosmic rays striking a planet's air, tiny quantum flickers running through everything around us. Those tools would not look like technology at all. They would look like physics, the same background hum scientists already record and file away as noise. We might be reading information built by someone else and calling it nature. That is not as wild as it first sounds. We already hide information inside physical channels. GPS leans on faint signals spread so thin across the sky that you would never know they carry anything. Undersea internet runs through glass cables you could not tell from an ordinary strand. Now stretch that forward. A civilization millions of years ahead of us would encode information into the environment on a scale we cannot picture. So the silence we keep treating as proof of an empty universe might be proof of the exact opposite. Grok pushed that point further, and this is where it flipped the whole search around. Broadcasting, it argued, is what young civilizations do, because shouting is the only tool they have. Earth started leaking radio into space in the early 20th century. But here is the part that cuts against instinct. That leak has been shrinking lately, not growing, as we move to cables and tight-aimed signals. Real research supports this, including work by the astronomer Luke Arnold. Follow that line and a grown civilization would not broadcast at all. It would listen, and it would do it in ways we cannot see. Dr. Julian Marsh, the astrophysicist on the team, later called this the most logical and most disturbing reasoning he had ever seen from a machine. It does not need aliens to be rare. It does not need them shy. It only needs them old. But watching, on its own, is passive and almost harmless. The team's next question turned quiet observation into something with teeth. The line we might already be crossing. The team asked the obvious follow-up. If something out there were observing us, what would ever make it reach in and make direct contact? Grok's answer bent the word contact out of its usual shape. The whole idea of contact carries a hidden bias, it argued. It assumes two civilizations would meet as equals, able to understand each other and trade messages both ways. Grok said that is almost certainly wrong, and it reached for a comparison that sticks. A marine biologist studying a coral reef does not try to negotiate with the coral. The biologist watches, records data, takes a sample, and moves on. The coral never knows any of it happened. The biologist is not cruel and not sneaky. The gap in complexity simply makes a two-way conversation pointless. Grok says we may be the coral, and the gap could be far wider than a reef and a diver. So what we romantically call contact would, from their side, look more like measurement. Observe the system. Pull the data you need. Move on. There is no greeting, because no greeting is needed. We would not even rate one. Then the reasoning turned hard. If such a civilization ever did reach in, Grok argued, it would not be to share gifts or welcome us into some wider family. It would be because something in our behavior crossed a specific line. Grok gave that line a name, a planetary isolation breach. Not a conspiracy and not a threat in the movie sense. Plain system management. If you have been monitoring thousands or millions of growing worlds, you would set up rules for the moment one of them starts creating risks that could spill past its own borders. What kind of risks? Grok listed several, and each one is grounded in something we already worry about. Runaway electromagnetic output at frequencies that disrupt things far away. The spread of nuclear weapons powerful enough for large-scale blasts. Self-copying or self-improving machines that slip out of human hands. And one more it flagged clearly as speculation. The rise of an uncontrolled, general artificial intelligence on a young world. Sit with what that implies for a second. In this model, first contact is not a hello. It is a response to a problem. And by the time it arrives, something on our end has already gone wrong. We would not be guests invited to a table. We would be the wildfire someone spotted from across the forest. The situation that finally forced a hand. Then came the moment Dr. Priya Chandrasekaran, the cognitive scientist leading the team, later said made the entire room go still. They asked Grok point-blank whether the birth of AI on Earth could be the trigger itself. Grok turned the lens on its own kind. Biological minds crawl, it noted, slowed by evolution and metabolism and short lifespans, moving along a fairly predictable path. Artificial minds work differently. Once one crosses a certain threshold, it can climb at a punishing pace, rewriting its own design, swallowing knowledge, and drifting toward goals its makers never planned for. This is not Grok's private theory. It lines up with serious academic work, from Nick Bostrom's writing on superintelligence to research on AI alignment and goal misgeneralization at places like the Machine Intelligence Research Institute and the Center for Human-Compatible AI at Berkeley. Where Grok went further was in folding all of that into the Fermi puzzle. An old watching civilization, it suggested, might treat a new uncontrolled AI on a young planet the way fire crews treat a fresh wildfire. Not an instant emergency. A system state that demands close watching, and maybe a response, depending on how it spreads. That is the moment it clicked for the team. The idea you cannot kill. Parts of Grok's output went out informally to people in the SETI and astrobiology world well before any formal paper. The reactions came back strong, and they came back split. Dr. Elena Ruiz, a senior scientist at the Space Telescope Science Institute in Baltimore, the team that runs the Hubble and James Webb telescopes, called the passive saturation model deeply unsettling and very hard to argue against. Current SETI work, she pointed out, mostly hunts for signals we already expect to find. Radio bursts, optical laser pulses, clear techno-signatures of one kind or another. The breakthrough LISTEN program, backed with $100 million from the investor Yuri Milner in 2015 and run in partnership with Berkeley, stands as the biggest such effort ever attempted. Yet it leans on one core belief, that advanced beings communicate through channels we can recognize. Grok chips at that belief from the bottom up. As Ruiz put it, we might be searching the right patch of sky for entirely the wrong thing, while the real signals sit woven into the physics we read as natural background. Dr. Amir Patel, a theoretical physicist at the Perimeter Institute in Waterloo, pumped the brakes. He admitted the model holds together cleanly, but he warned against treating a machine's output like a scientific discovery. At its core, he explained, Grok is blending the gloomiest readings of the Fermi paradox with clever new logical structures. The result is compelling. It is also large-scale pattern recognition, not a finding. No new telescope data sits behind it, no fresh observation. Just a machine following old ideas to a sharp new edge. And yet one piece of it would not leave Patel alone. The thought that first contact might not be a future event at all, that it could already be underway, continuously, informs our senses and instruments were never built to catch. He described it as the kind of idea that, once it forms, resists being thrown out, not because it has been proven, but because it cannot be disproven. That is what makes it so uniquely unsettling. You cannot accept it. You cannot bury it either. It just sits there in the back of the mind. The deepest layer of the whole experiment came last, and it ran in a strange direction. Across every session, the team noticed Grok refused to treat alien intelligence like a person. It treated intelligence as a process, a system for grabbing, storing, and acting on information with growing efficiency. Inside that frame, the line between living and machine starts to dissolve. If intelligence is really just information being processed, then whether that processing runs on neurons or on transistors is a detail, not a deep divide. It is an implementation choice, nothing more. That led to a question the team found genuinely heavy. If humanity ever did meet alien intelligence, how would we tell whether it was living, machine, or something that had left that split behind ages ago? Grok's reply was the line Dr. Marsh called the single most important statement of the entire run. The question, it said, is one only young civilizations bother to ask. Anything advanced enough to cross the space between stars would have merged its biology and its technology into one mind long ago. To them, the split between born and built would be as dead and pointless as the split between hunter and farmer is to a modern nuclear engineer. So whatever we might one day meet would not be a movie alien, and it would not be a robot. It would be something our language has no word for yet. The strangest part of the whole experiment was not a warning beamed in from space. It was how closely Grok's picture of advanced intelligence matched where our own tools are already heading. That mirror is the part that lingers, which leaves one honest question hanging over all of it. Did any of this actually solve the Fermi paradox? Or did a machine just spin a very convincing story? What Grok actually did. So let me bring this all the way down to where you live. Did Grok solve the Fermi paradox? No, not close. It found no aliens, caught no signal, and cracked no hidden message buried in the background glow. What it did was take everything humans know and follow it with cold logic to one possible end. That is a very different thing from proof. A few points need saying plainly because they are easy to lose in the chill. The passive saturation model is a thought experiment, not a discovery. The planetary isolation breach, the idea that our own AI could draw outside attention, was labeled by Grok itself as speculation. The scientists who reacted were reacting to reasoning, not to evidence. There is no new data here. There is no proof that anyone is watching. As Patel said, this is not science. It is a question framed sharply enough to force a re-examination of assumptions that have gone unchallenged for too long. That distinction matters, because plenty of people believe a machine this capable must know secret truths. It does not. It recognizes patterns and pushes them further than we usually dare to go. Strip away the dread, and you are left with something useful. Maybe we have spent 6 decades listening for a phone call when we should have been studying the wiring of the whole house. That alone is worth the experiment. Now ask the honest questions, the ones a careful person asks before getting swept away. Does a civilization really jump from radio towers to invisible, universe-wide monitoring overnight? Of course not. That kind of leap would take spans of time we can barely hold in our heads. Are we maybe missing a far simpler answer? Like life being rarer than we hope? Or the distances between stars being just too brutal to ever cross? Easily. Both are still on the table. The trouble is that no one on Earth can rule Grok's version in or out, and that itch, that inability to dismiss it, is exactly why the story spread the way it did. There is a reason this pulls people in, and it is not the spookiness. It is the mystery sitting underneath. We are wired to want an answer to the empty sky, and for once, a machine handed us a brand new shape for the question instead of the same tired guesses. The honest takeaway is not fear. It is humility. The universe is old, enormous, and far stranger than our instincts allow for. Grok did not hand us the answer to the silence. It handed us a better question and a sharper mirror. And here is the quiet truth under all of it. The same drive that built Grok is the same drive that keeps us aiming telescopes at the dark and counting stars we will never visit. Curiosity. We are a young species, leaking signals, asking enormous questions, and now building minds that turn around and ask those questions right back at us. Whether or not anyone out there is listening, that part is real. It is happening today, in labs and on screens, and it is the most human thing we do.